Welcome to this WiseOwl DAX for Power BI tutorial. In this part of the series, we're going to be looking at how to work with dates in your calculated columns. We're going to start by looking at Power BI's automatic date time feature to create some date parts for you automatically, and then look at how to calculate those same date parts using a variety of different functions. We'll look at putting those separate date parts together into a hierarchy, and then look at how to use that hierarchy in your report visuals. We'll also explain how you can compare dates, and that's going to involve writing either date literals or using the date function to construct a date out of its separate parts. We'll also look at how you can calculate future and past dates by adding or subtracting days to your dates. And then at the end of the video, we'll look at how you can work out the difference between two dates, either by subtracting one from the other or by using the DateDiff function. So plenty to do in this one, let's get started. To get started, I've created a new blank Power BI report, and just before we choose to import some data, I'd like to check out one of Power BI's settings related to dates and times. So we'll head up to the File menu, and then choose Options and Settings, and then choose the Options option on the right hand side. And when the dialog box finally loads, we'll have a look on the Data Load page of the Global section. So down towards the bottom of the page here is an option to do with time intelligence, and this little checkbox about auto date time for new files. Now you can read an awful lot of detailed information about this by following the Learn More link to the Microsoft documentation. But basically all you need to know for this video is that if that setting is enabled, when you import data into your data model, Power BI recognises date time columns and will automatically generate a background calendar table for each separate date time column that it finds. And this provides quite a few advantages for working with dates and times in your visualizations. So the first example we're going to create is going to rely on that automatic calendar that's created. So I'm going to make sure that this option is checked. Bear in mind that if you've had to change this setting just now, the change will only affect new files that you create, so it won't affect any existing report that you had open. So with that setting enabled, I'll click OK, and then I'm going to choose to import some data from an Excel workbook. I'll double click on the Movies workbook, and again, as usual, I'll drop a link in the video description so you can download that file yourself. And then when the import wizard loads, I can check the box next to the Movies worksheet, click the Load button, and we'll find that when the data has loaded, if I expand the fields list on the right hand side, I can spot the single date time column in that dataset with the little calendar symbol next to the release date column name. This automatic date time feature provides lots of advantages for working with dates in the report view, although you don't get much of a clue about that if you were looking at the date column in the data view. If we just switch there briefly, you can see it just looks like a regular column of dates. If we switch back to the report view, however, and we simply include the release date in a visual by checking the box next to that column, it doesn't just insert the individual date, it breaks the data up into a year, quarter, month and day component. Different visuals display that in a bit more of an interesting way as well. If I just change the table into a matrix visual, by clicking on the matrix tool in the visualizations panel, I can now drill down into each individual year, and then each individual quarter in the year and month in the quarter to see a breakdown of values based on days, months, quarters and years. That is reflected as well in a slightly different way in a chart. So if I change my matrix into a clustered column chart, at this point we'll need to include some data to display, so let's include the box office field, and then I'll just change the aggregation there to an average rather than a sum. So at this point we're showing an individual column for each year, but if I enable the drill down feature, I can then click on a column for a year to see the quarters of that year, and then click on a quarter to see the months, and then click on a month to see the individual days. And then I can drill all the way back up again to see the data at the year level. I don't have to see this data broken down by this date hierarchy, by the way. If I wanted to see the individual dates, it's fairly simple to switch from the hierarchy to the individual dates. So once you've added the release date field to a visual, you can click on the drop down arrow next to it and choose to show the release date column rather than the date hierarchy. So that will now show a separate column for each individual date in my data model. I can then go back to the hierarchy by clicking the drop down arrow next to the release date and choose date hierarchy again. I can also choose individual parts of the date hierarchy. If I wanted to, I could show this data broken down just by month, for example, by removing levels of the hierarchy by clicking the crosses next to them. So now I'm showing a breakdown of average box office by month of release. I don't have to add the release date column first. I could pick a specific level of the hierarchy when I first build the visual. So if I get rid of the release date column from the axis bucket entirely, you can expand the release date and then the date hierarchy contained within it to select exactly the level that you want when you build your visualizations. So lots of advantages there for working with dates when you've got this automatic date time feature enabled. Now let's compare this report with one that we create without the auto date time feature enabled. Just before we do that, I'm going to save this report and give it a sensible name, something like auto date time or auto calendar, something like that, and then save that. And once that's finished, we'll head up to the File menu and we'll choose Options and Settings, Options, and then we'll temporarily disable the auto date time feature. Now you may be wondering why I'm choosing to disable this feature if it's so useful, and there are several reasons you might consider doing this. The main one is probably if you're choosing to create your own custom calendar table to work with the date time intelligence features of Power BI. That's something we're going to talk about in a lot more detail in later videos in this series. It's also worthwhile bearing in mind that the automatic date time feature only works under certain circumstances, and you can read a lot more about those in the Learn More link in the Microsoft documentation. So it's definitely worthwhile learning how to work with dates without the automatic date time feature. So let's click OK, and then we can choose to create a new report. So I'll head to the File menu and choose New, or I can just press Ctrl and N on the keyboard. And when the report has created itself, let's close down the splash screen there. We'll choose to import just the exact same Excel workbook. So let's import the Movies workbook. And then when the import wizard is loaded, we can check the box next to the Movies worksheet and then choose to load that data. And when it has finally loaded, we can expand the Movies table on the right hand side. Eventually, there we go. And you'll see we have imported the release date. There it is. If we look at the data view, it doesn't look any different in the data view. It just looks exactly the same as the previous example. But of course, this time you'll notice the lack of little calendar symbol next to release date. And if I did check the box next to release date, it creates a table, but it doesn't break that down into the individual component parts of the hierarchy because that hierarchy doesn't exist. So let's say that we wanted to recreate that date hierarchy. The first thing we'd have to do is calculate the individual bits of the date that make up the hierarchy, and that's actually relatively straightforward because DaX has some built-in functions for separating dates out into their component parts. So let's head back to the data view, and we'll start by calculating the year from the film's release date. So we can create a new column, and I'm just going to call it year. Let's just zoom in so you can see a little more clearly what I'm doing. So I'll create a new column called year, and I'm going to use a function also called year. So we'll say year, open some round brackets, and then we need to pass in a reference to the release date column. We can then close the round brackets and hit enter, and now we've got the year component created already. We can continue that theme if we create another new column. We'll create a column called quarter, and I'll make this equal to, you've probably guessed it already, the quarter function, and pass in the release date. Close round brackets and hit enter, and there's the quarter. I'm going to create the next column. I'm not going to call it month. I'm going to call this one month num or month number. And the reason for this is that when we use the month function, which you may well have predicted already, the month function returns a number from 1 to 12. So we need a slightly different way to get the month name. But let's start by calculating the month number. This is still going to be a useful piece of information. So we'll include the month Movies release date. And then to get the name of the month, we're going to use a function you may have seen in the previous video, the format function. So let's create a new column called month, and we'll make this one equal to format, open some round brackets, and then there are two parameters to fill in. We'll refer to the release date first, and then the format parameter in some double quotes. I'm going to format this with 4 M's to get the full month name. So that will be January, February, etc. 3 M's would give you Jan, Feb, etc. So if you prefer a short month name, then go for 3 M's. 4 will give you the full name. Close around brackets and hit enter, and we'll get the month name. And then finally, in terms of calculated columns, I want to calculate the day of the month. So one more new column, and we'll call this one day. And we'll make this one equal to, and once again, you've probably guessed, the day function. So we can pass in a reference to the release date, close the round brackets, and hit enter. And then at that point, we've got all the components of the hierarchy that we need. Next, we can create the date hierarchy, and probably the easiest way to start with that is to right-click on the year field in the fields list and choose Create Hierarchy. So you'll see that gets added into the fields list, and you can expand it with a little arrow symbol to the left of it to see that you've got the year field sitting within it. Let's just rename the hierarchy before we add any more fields to it. I'm going to double-click on its name, and I'll call this one Release Date Hierarchy. I'd like to call it just release date, but of course that name's already taken by the original column. So once I've renamed it, we can add more fields to it by right-clicking on the field. So let's go for the quarter field next. Add to hierarchy, release date hierarchy. And then just do the same thing with the month field and then the day field as well. So you'll see all those fields added into that hierarchy. Finally, just to give it a quick test, let's head back to the report view. And in this table that's currently showing the release date field in the values bucket, let's get rid of release date and replace that with your release date hierarchy. So just as we did in the other example, check the box next to the hierarchy to add all those separate values into that table. There are a few extra things we can do to make this example a little more similar to the example we created earlier with the automatic date time feature. First of all, I'd like to hide the separate columns that appear in the fields list in the report view. We can access all of these from the hierarchy itself, so it's pointless seeing them listed twice. We can change that in a couple of different places. We could go back to the data view, and then next to each one of these individual columns, we could click the little eye symbol to hide it from the report view. When we have multiple columns to hide, it's probably a little easier to select multiple columns and hide them in the model view. So if we switch over to the model view and then select the first column, day, then hold down the control key and click on each of the other calculated columns that we wanted to hide, we can then click the single eye symbol and hide them all at the same time. So if we switch back to the report view now, we can see that those additional columns are hidden from the fields list, making it a little easier to work with. Next, I'd like to improve the appearance of the value displayed in the quarter column. In the auto date time example, if I just give myself a bit of space to insert a new table, if I insert the quarter column, it's shown with the letters QTR in front of the number. So to make that work, if you remember from the previous video, we can concatenate values together to form larger bits of text. So from the report view, I could highlight the quarter column, and then if I just zoom in again on this formula bar, we could add the letters QTR followed by a space, in some double quotes, and then use the ampersand to concatenate that with the number generated by the quarter function. And if we update that expression now, we'll see a slightly more readable value for the quarter. One final improvement I'd like to make is in the way the month column works. If I just switch back to the auto date time example we created earlier, and if I get rid of the quarter column from that table and then just add in the month column instead, you can see that sensibly it's sorted chronologically from January through to December. If I try to do a similar thing in our new example, if I click into a blank part of this page and then just insert a table, and then if I choose to include the month column, I could then get rid of the year and the quarter, you can hopefully see that the month names are sorted alphabetically from April through to September, which isn't particularly useful. So the reason we created the month number column earlier on, if we head back to the data view, we can select the month column, and then from the column tools tab, we can choose the sort by column option and choose to sort the month name by the month number. So once we've done that, if we head back to the report view, we can see now that the month names are sorted chronologically from January through to December. So that was quite a lot of effort to recreate something that, in most cases, Power BI could have created for us automatically. So let's look at a few things that the automatic date time feature doesn't do for us. We'll start with a simple example of adding a different interval of time. I think it would be nice to be able to analyse our films based on which day of the week they were released on, and that's not something that the auto date time feature creates. So let's head back to the data view of our report, and then the way we do this is kind of similar to how we did it with the month number and month name. I want to add in the month names, of course, so we can see Monday through Sunday, but have them sorted chronologically rather than alphabetically. So let's create a new column to calculate the number of the day of the week. So let's call this one something like weekday num equals, and then we'll use the weekday function. Now there are two parameters here. The first one is a reference to the release date, and then the second one is what day you want to consider the first day of the week. So we have a few different options here. We can choose Sunday as 1 through to Saturday, or Monday as 1 through to Sunday, or Monday as 0 through to Sunday as 6. I'm going to go with Monday 1 through Sunday 7. So I always consider Monday the first day of the week. So we can then close the round brackets and hit enter, and that'll give us the weekday number. Creating the weekday name is fairly straightforward. We can just use the format function. So let's create a new column, and we'll call this one weekday, and we'll make this one equal to the result of the format function using the release date. And this time we'll use the code DDDD to get the full name of the day of the week. Close the round brackets and then hit enter, and there's our day names. With that column selected, I'm then going to choose the sort by column and sort this by the weekday num. Finally, I'm going to make sure that the weekday num column is hidden from the report view. So I only need to do this for a single column now, so I can click the I symbol next to the weekday num column in the data view. If we now head back to the report view, let's just use our existing table. Let's swap out the month field from the hierarchy. Let's replace that with the weekday field. And then we could add in the, let's go for a count of the film ID. If I add in the ID column, that will automatically give us a count. And then perhaps we could change that into a clustered column chart to see a slightly more interesting view of the results. So no great surprise that many films are released on a Friday, I think. Next, let's have a look at how we can use dates in comparisons. I'd like to divide my films into old and new films, depending on whether they were released before the 1st of January 2000. And yes, I appreciate it is a bit of a stretch to consider 21-year-old films as new, but it's just for this example. The first way I'm going to do this relies on a feature that was introduced in the August 2021 edition of Power BI Desktop. If you're not sure which version of Power BI Desktop you're currently running, head to the Help tab in the ribbon and choose About, and then it shows you exactly which version you've got installed. So I'll show you the technique that will work for versions prior to August 2021 if you're not already running that version. But for the first example, let's head back to the data view and we'll create a new column, and I'm going to call the column old or new equals, and then use an if function to test if the release date column has a value that's less than. And then this is the thing that only works from August 2021 or later. If I type in the letters DT and then in some double quotes, I can type in a date literal. I must do it in a particular format, a format people who use SQL should be fairly familiar with. Start with the year, followed by a dash, and then the double-digit month, and then another dash, and then the double-digit day as well. So that's the 1st of Jan 2000. If I type in a comma and then shift and enter, on the next line I'll describe that sort of film as an old film, followed by a comma, and then on the next line we'll say new. When I close the round brackets and hit enter, we'll see a combination of old and new values in this column. And if we switch back to the report view, we could add that field into our existing chart perhaps. Let's add it to the legend bucket and see if there's a difference for day of the week of release according to whether a film is new or old. It appears to follow the same general pattern. So how do we do the same thing if we're using an earlier version of Power BI Desktop where we can't write a literal date into an expression? I'm going to select the old or new column in the fields list. I'll just stay in the report view to make this change. And then rather than writing the literal date preceded with the letters DT, we can use the date function. So if I open some round brackets after the date function, I can specify the year, followed by the month, followed by the day, and you must use numbers for all of those components. And then when you put all those values together, the date function produces a complete date from those individual values. So if I hit enter again, we'll end up with exactly the same results, but this one will work in whichever version of Power BI you're using. Next, let's look at how to calculate future and past dates in DAX. And I'd like to start by looking at a function you may be familiar with from other Microsoft products called DateAdd. There is one big difference with DateAdd in DAX that I'd like to show you. So to demonstrate this, I'm going to go back to the data view. I'd like to be able to see the results of my new column here. And we're going to imagine that each film has a limited run at the cinema of 28 days exactly. So for each film's release date, I want to calculate the date that's 28 days in the future. And that's great because it lets me use a silly movie-related pun, so I can create a new column called 28 days later. And we'll make this equal to the DateAdd function. We specify first of all the column containing the dates we want to add or subtract time to or from, so that's movie's release date, followed by a comma and then the number of intervals. If we wanted to subtract days, then we just use a negative number, of course. Here we want to add days, so I'll use the positive number 28. Follow that with a comma and then say what interval of time we want to use. So in this case, it's going to be a day. If I press enter now, the results are slightly unexpected. While some films do calculate a date that is 28 days from their release date, many films don't. And here's the big difference with the DateAdd function in DAX. In order to return a date, that date must exist in the column you specify here. So the DateAdd function is actually much more useful when we use the date time intelligence functions. So when you have a proper calendar set up that your date fields are connected to, the DateAdd function becomes much more useful. And again, we're going to be covering that in more detail later on in this series. So the easiest way by far to get this to work is not to use the DateAdd function at all. Let's get rid of the most of this. We're just going to arithmetically add the number 28 onto the movie's release date. So much like in Excel, you can treat dates just like numbers and you can add and subtract numbers to and from them. The value of 1 represents a full 24-hour period. So if I say add 28 and then update this formula, it calculates 28 full days from the movie's release date. Of course, the number of days that you add or subtract doesn't just have to be a hard-coded number like this. That value can come from a column. So, for example, let's imagine that the run time column wasn't the runtime in minutes of the film, it was the length of time that the film was released at the cinema. So we could add the value of the runtime column to this release date by saying release date plus movie's runtime, and that will calculate a date that's a variable number of days in the future. But that doesn't really match any longer the title of this column, so let's change that back to 28 just to complete that example. We can use similar basic arithmetic to work out the difference between dates. So let's say we wanted to work out the age of the film in days. We could subtract its release date from today's date. Let's do that using a new column. We'll call this one age in days. And then we'll make this one equal to the date function. Let's say we wanted to use a single specific date first of all, so we'll say date 2021, 8, 24 to construct today's date, and then subtract from that the release date of the film. Now when we hit enter, the end result doesn't look like the difference in days. It presents the result as a date time value. If you wanted to see what the underlying value of that formatted date was, we could change the data type of the column from date time into a whole number. We'll have to confirm that we want to do that. So it shows us that the first film at least is 5,177 days old. One of the downsides of the technique we've just used here, of course, is that that date won't ever change. It's a fixed point of 24th of August 2021. It would be a little more useful if we could calculate the current date and that would update when we refresh our data model. So to do that, we have a couple of functions we could use. Again, you may be familiar with the today function from Excel. So there's today, and there's also a UTC today, so the coordinated universal time. So today uses the time zone that you're in, or at least the time zone that your server is in. So I'm going to use the today function, open and close and round brackets. There are no parameters for this function, it's just today, open and close round brackets. Hit enter to update the formula, and we'll see the same end result. The difference is that when we refresh this table, the today function will recalculate to give us the current date. Now there is actually a function in DaX designed to calculate the difference in dates. Again, it may be one you're familiar with from other Microsoft products, called DateDiff. Let's use the DateDiff function to calculate the difference in a different interval of time. So I'm going to create a new column, and I'm going to call this one diff in years. Equals, and then use the DateDiff function. We simply specify two dates and then the interval of time we want to calculate the difference in, and you must start with the earlier date. So in this case, that's the release date. And then the second date will be the current date, so let's use the today function again. And then you can specify what interval of time you want to use. So we've already seen the example for days. Let's go for years this time. If I close the round brackets and hit enter, we'll calculate the difference in years between the today's date and the movie's release date. Now, when you're using the DateDiff function to calculate the difference in years, you should be careful not to assume that it's calculating the age in years of a thing, or of a person, more importantly. If we have a look at the examples we've created here, the first 3 or 4 rows calculate the difference in years as 14 years. And if we just head backwards to the release date column, all those films were released in the year 2007. So Evan Almighty turned 14 on the 22nd of June in this year, 2021. But the other 3 films, Beowulf, B-Movie and I Am Legend, haven't actually turned 14 yet. Their birthdays are a little in the future in November and December. So what can we do to resolve this sort of a problem? There are several solutions to this. You may already have your favourite preferred method for calculating age in years rather than just the difference between the years. I'm going to show you a fairly clunky technique, but it relies on techniques we've covered in this video series so far, so it's a nice little reminder of some of the things we've already done. So I'm going to create a new column, and I'm going to call this one age in years equals, and then I'm going to start with an if function. I'm going to check a couple of conditions. First of all, I want to check if the month of the release date of the films is greater than the month of the current date. So I'm going to use the today function to do that. If that condition is true, then I know that the film's birthday is definitely in the future, so it hasn't actually hit the age of 14 yet, for example, for B-Movie. At this point, I'm just going to hold down the Alt and Shift keys and tap the down arrow key to duplicate that condition on the next line. Then going back up to the first line, I'm going to add an OR operator by typing in the 2 vertical bars. I might just zoom out a little bit just so I can get everything else onto a single line. Okay, so on the next line, I'm going to wrap a set of round brackets at the beginning of that line. And then I'm going to check if the month of the movie's release date is equal to the month of today, and using the double ampersand operator, the day of the movie's release date is greater than the day of today's date. I've completely failed to give myself enough space. I might break this onto a couple of different lines in just a moment. So let's just finish off this. Day of today, close the round brackets for the day function, and then close the extra set of round brackets corresponding to that first one I added at the beginning of line 3. Let's just break this onto a separate line, in fact, just to make it a little easier to see. Okay, so basically we're asking if the month of the film's release date is in the future, after the current month, or if the month is the same as the current month, but the day is after the day of the current day, then we know the film's birthday hasn't yet happened. I did say this technique was a bit clunky, didn't I? Let's type in a comma at the end of that logical test argument for the if function, and then on the next line we can calculate DateDiff between the release date of the film and today's date in intervals of years, and then simply subtract 1 from the result to get the actual age of the film. Again, at this point I'm just going to hold down the Alt and the Shift keys and tap the down arrow key to duplicate that line. Then just going back up to the previous line, type in a comma at the end, and then on the next line get rid of the -1, we don't want to subtract 1 from that, and then finally close the round brackets for the if function. Phew, okay, quite a lot of code to do something quite simple, but the important thing is when we press enter, we'll see that we've now adjusted the age in years according to whether or not the film's birthday has passed. So quite a lot of effort, but the end results I think are worth it. So there you go, there's some of the basic things you can do when creating calculated columns with dates in your reports. We're going to revisit a bunch of those ideas when we talk in more detail about date-time intelligence and calendar tables later on in the series, but I hope you found that one useful so far. Thanks very much for watching, and we'll see you next time.